Hi everyone, and today we'll be talking about one interesting topic called ChatDev. So basically, ChatDev is a system of agents that work from start to end, okay, from the idea formulation all the way to executing out the code. And like, for example, you want to create like a Gomoku game, then it can simulate like a software company trying to get the game out. Okay, obviously, it's not going to be as good as a real software company because agents is quite new. But let us see how far this can push the frontier and what are the limitations. So with one system, you can see that they have created multiple programs. All right. One thing that strikes me is that these programs kind of look a little simple. Okay, that kind of highlights what kind of programs that can be done right now. Like maybe if I want to create a very big browser or a database, it may not be possible. Like a game like maybe MapleStory may not be possible as well, requires too many files. Okay, but simple apps, okay, like a timer, like create a bar chart. I think those are all possible stuff. So now I tried to do something that is a bit different from what they have done. Okay, I want to just show you the results. So let me just upload the log here. So there's this very nice log you can, once you run ChatDev, okay, from the GitHub, you can actually upload your log and then you can replay it here to see it live. So this is how ChatDev works. Okay, at the start, you give the requirement. So the requirement is like this. I said, create me a Wheel of Fortune game with beautiful graphics in Pygame. And then we have the chief executive officer starting it. And then we say that, okay, this is what you have. And you notice that they ground the agents using a text prompt. So the text prompt can be like, okay, you can only use the following tools like image, document, and so on. Okay, one thing I would like to say about ChatDev is that there's not really tool use here. It's mainly like prompting the agent in text, and then the output of the agent is all mainly in text as well. So this is quite a big limitation, but I think with improvements, this can be linked to other tools and external APIs and so on. So the CEO is now talking to the CPO, the Chief Product Officer, to see like how can we create this. Of course, I already gave it Pygame, so all right, extracted the right thing. So over here, you see over that there's stuff like info. Okay, so this is something that is unique to this ChatDev system. It's because if we do not have this kind of tokens to say that, okay, we have decided on something, what they have found is that agents communicating with each other like that, they might lead to an infinite conversation. They might never end. So this kind of tokens will kill the end of the discussion. So at each point of time, there will be two people discussing. So now this like the CEO discussing the CPO to come up with how do we do the product and so on. So after that, there's a discussion with the CTO as well. All right. So this is the template that is used. So this will ground the way the documents will be generated later on. So it's quite cool. I mean, there's a process flow. After that, the programmer will then create the Wheel of Fortune game, and out comes the code following the template earlier. And we can see that this is in Pygame because we have specified Pygame, and also the CTO decided Python as well, and CPO decided Pygame. So all these earlier generations are passed on to the later when the process goes to the later parts. We also use whatever has been decided earlier on. It's decided earlier on to ground the generation. So you can see that this is what has been passed down, like the task, the modality, the programming language. Okay, and some ideas as well. Now is the idea. So now think step by step. You can see that there's some prompts, okay, to ask them to generate detailed steps, okay, broad steps and detailed steps. So I quite like this way of streamlining the generation from a very broad concept all the way to a very, very specific one. So you can see this is the program that has been output, and they output not just the main, they also output like the other stuff as well, the wheel, the player, and you can see this is what happens now. So now this if you look at the illustration here, this is the coding step. Okay, let's just skip all the code for now. We generate quite a lot of code. Okay, and then right now we need to do some testing. So let's go to the testing part. So where's the testing area? Let me just see whether we can find it. So now the programmer is iterating with the chief technology officer to like generate the code. Okay, let's just increase the generation speed. Okay, where are we now? The programmer. Right, so this is actually quite reflective of the actual software development process because the programming part is actually quite one of the longest. Okay, programming and debugging parts. All right, so where are we? So you can see that they iterated over the code many times. So when one person does the code, the other person might say, hey, you haven't done this part. Then you do the code again and so on. So this is actually some form of reflection. So after you have generated your output, the other person will function as your reflector. They will critique whatever you have done and then tell you, okay, what you need to do next. So it's a very interesting framework because this is exactly like maybe if you communicate with other people, you present your ideas, someone will tell you back. Okay, you can also do self-reflection. You can say that, okay, I think this is the case. Let me check, let me verify whether it's the case. So this can be done in like as a single agent or as multiple agents. Over here, they chose the multiple agents framework. So yes, I want to show you this part. This is the code reviewer part. So the code reviewer would take in the code, okay, the form of a prompt, all right? Or rather, this is the context that is given. This whole thing, all the different files will be given as the prompts. Okay, I don't know if you can see this. You can see this. This is the main.py. Then we have the wheel, we have the player, the game, and then after that, all right, the code reviewer will then base on this text, okay, and say, okay, what is the thing that needs to be fixed? So we forgot to import the other files. So this one needs to be added in. So this I tried my best to find in the code to see whether they actually run it out in the IDE, in the integrated development environment, but I couldn't find that line. So I suspect that this code reviewer is just purely based on the text to review it. So that's not ideal, okay, because this is something that should be done in the environment itself. Okay, but after the code review is done, they correct the code. Okay, this takes a while. Let's just skip all this. Okay, after they get the code out, what we'll do is we will then try to form the requirements for all this. So after all this, we have like the requirements can be just gotten from just the text alone. That's quite remarkable. But of course, this means that the requirements might not be the correct ones as well because it's just inferred from the text of the code. So other than the requirements, we also come up with like the user manual of how to install this. So like first, you see over here, we have this is like how the manual should look like. This is an example using like LangChain. So let's see what's the user manual that they generated for us. Welcome to the Wheel of Fortune game. It's built using the Pygame library and interactive environment. Then this is basically how you install it. Okay, you have this, you install the requirements. And then after that, you can use the left and right arrow keys to spin the wheel, press any letter A to Z, and then press escape to quit the game. All right, we just need to key in this Python main.py. All right, and that's the end of ChatDev. So quite remarkable. They simulated the whole thing. So this is obviously not within the testing set that they have. I just decided to see whether they can create a game that is like not really created online. I mean, if you search Wheel of Fortune game, I don't think you can find a Python source code. Let's search Wheel. Oops. Yeah. Yeah. So I don't think there's anything in Pygame online for Wheel of Fortune. Okay, maybe it's like Python and so on. So this is something that is not easy. Okay, because we don't have this in Pygame online. I don't think this is readily available. So the computer needs to imagine this out. So let's see how this end product looks like. So after you run your ChatDev, you will actually go into this. You can see this, right? These are all the files that are generated. And we can see that like this is the main.py. Just take a look. This is the code that was generated. And all the other files, you can see that main, game, player, wheel. So all these are the stuff that can be generated by the AI itself, which is not too bad. Let's see whether it works. So I'm just going to the terminal. Okay, I'm just going to type in Python main.py. Okay, can you see this pop-up window?
Yes.
Okay, so let's see. In the instruction manual, they tell me I can go left and right to play it. Okay, I click left and right, and actually nothing happens. So, so I'm keying in the letters now. So at least like the letters kind of work, but not all the functionalities work. So this is the outcome of the game. Yeah, I would say that it's not say that bad because they have some semblance of like, oh, we have a player, we have a wheel. Okay, although the wheel did not appear. All right. So these are some stuff that needs to be iterated more. And the main thing that I would like to say is that perhaps the detailed steps of how the game should be created was not really there. Like we don't really have, okay, we want a main menu, we want a next page where the user keys in the like press the start button and goes to a stage and then load the stage and so on. So when you create a game, actually all these things need to be there. You need to plan out like where are your scenes and so on. So this is missing in ChatDev. They created me one basic game, which doesn't work fully. Okay, but for the tester, because if you see the tester just now, they just basically based on the text, and then the text looks okay, looks runnable, good. They passed the unit test. Yeah, so this unit test is not robust enough. But apart from that, I think the idea is quite interesting. All right, I'm going to stop share now. I'm going to go to the slides and continue the rest. So, okay, to be honest, I was slightly disappointed. Okay, I thought that since this ChatDev is quite hyped up these few weeks, I thought it could create the game. Right, but it turns out that there's still a lot more to be done. Okay, this is not the ideal state that we should be. All right. So some background for why ChatDev can work. Okay, the first part of ChatDev is actually this thing called the CAMEL, which is like the Society of Minds paper, where they ask themselves a simple question. All right. If I'm the person talking to ChatGPT now, all right, can I make AI replace me? Okay, so this is the idea. All right. So if you look here, this is the task that someone has. Like for example, you want to develop a trading bot for the stock market. So right now, like I kind of need to tell the ChatGPT that okay, I want to create this bot. All right, list me the steps needed and do step one, do step two, do step three. So the idea is, can I automate my instructions? So the instruction is basically given by the user right now, which is like the human, right? Can I have the AI be an AI user and type in this inputs for me? All right. So if that could be done, you essentially automate the entire process. So the idea is very simple. So you have you have a big task that you give as a human, and then the AI itself, it will probably do a more specific task like develop a trading bot, sentiment analysis tool, monitor social media platforms. Okay, this is actually quite a real life kind of bot that you can create, right? So if you want this kind of bot, now what we need to do when we talk to ChatGPT, we need to prompt it, okay, I want to create this, tell me what I should do. Then what's the step one, what's the step two? So the user needs to do all this, like you yourself needs to do all this. Let me just put this, yeah, user needs to do all this. Yeah, so this is obviously not good, okay, because if we need to do all this, then we need to spend a lot more time. So can we prompt it? And so that's the purpose of this paper. Let's see whether we can. So the prompt is very simple. They just basically added in some system prompt for the user and for the AI assistant. So the system prompt for the user is that, okay, you must only tell me, okay, based on my expertise and my needs with, basically they want you to like give an instruction, okay, to the assistant. So you keep giving me instructions until you think the task is completed. Okay, and then when the task is completed, you reply with this done token. So what this means is that when they simulate the user, okay, you need to basically ask the AI user is told to instruct the assistant, okay, and instruct according to the assistant's expertise, all right? And then at the end of it, the AI user is given a termination token. Okay, why is this termination token needed? Right, the first part is understood because you kind of need to give the instruction to the assistant, like your assistant, based on what the assistant can do. So you need to have the capabilities of the assistant and so on. So that's a given. Okay, why is there a termination token needed? Okay, this one is I think the answer is down there. You can see. The thing is, you look at this, thing here. Look at this. They keep on saying thank you to each other or goodbye indefinitely. So this is obviously not good. All right. And I think this is the reason why if we use AI agents in a chatbot fashion, especially if the chatbot is prompted using like or trained using RLHF, it can actually lead to very weird kind of artifacts, all right, like this. So that's why this token is there. So this is not exactly a good thing, but this is like a bypass for the current state of the art right now. Using ChatGPT and RLHF, you get this kind of artifacts. Right, so what about the assistant prompt? So the assistant prompt is, you are an assistant, okay? Never instruct me. So this is quite interesting because somehow if they don't put this prompt there, the assistant might take in because the AI user might say something like this. Like the AI user might say, do this. Then the AI assistant might copy this and also say, do this. Okay, so we don't want the assistant to instruct the user. You see, like we want it to be such that the assistant just does the job and reports that the job is done and so on. So it's quite interesting that they need to prompt it like that. Okay, you must decline my instruction honestly if you cannot perform the instruction. Okay, this is understandable also because the assistant cannot do everything. All right, if it's not within the capabilities or if it's not morally right, yeah, you shouldn't do this. Then also there's this like the frame of how the solution should be. Okay, this is just a formatting, not that important. And always end your solution with next request. So this is just a way to say that, we do not want the assistant to end the conversation. Because imagine that's this case, okay? The user says do this, and then the AI assistant says done. Okay, that's not exactly what we want because we want the task completion. Oh, sorry, not done. Maybe like the AI assistant says task completed. We don't really want the AI assistant to say task completed because this should be done by the user. Like the user needs to be satisfied with what's going on. Then we end the conversation. So this is the rough framework for the CAMEL framework where both the user and the assistant are both AI agents talking to each other. The user gives instructions to the assistant and the assistant will then reply whether or not the thing is done or if they cannot do, give reasons why. Yeah. Any questions on this before I move on to the ChatDev?
Yeah, small question about like how does the chatbot know what is legally correct or what is morally correct? Like, does it
Okay.
have pre-trained knowledge or something?
I think it doesn't have any because it's not like they have a constitution or something to refer to that what's correct or wrong. It's probably due to the training distribution of what they have seen to be correct or wrong, and they have they can form their categorization there. Especially with ChatGPT, they have RLHF. So with the RLHF, they already been prompted what is right and what is wrong. Like sort of because when you ask them to do something morally wrong, they can reply. ChatGPT can reply, this is not uh, I'm not allowed to do this or I'm not able to do this. Yeah. So this one, it's based on the training. If you don't use like this kind of RLHF stuff to train based on like what is acceptable or have no moderation capabilities to catch it, then it will largely be based on what kind of text is being trained on. Yeah. So if you train it on text that says that, certain things are moral when it's not, like, for example, you can say stealing is morally right in that kind of text. The AI will just learn the training distribution. So yeah, did that answer the question? It's really based on how it's trained.
Sure. Yeah, I guess there's no way to confirm it. Like when they're discussing it, you only at the end then you can see the product and then you can determine whether it's okay or not okay. But like I think that goes to the second question that I have. Like, can you interfere with the conversation halfway currently?
Oh, in this CAMEL framework or in the
Yes.
ChatDev?
ChatDev, yes, ChatDev.
Yeah, in ChatDev you can interfere. So later I will touch on where the interference can be done. So you can actually create your own phase because they go by phases. You can create your own phase where you can interfere with or not interfere, you can be one of the agents. So instead of the AI agent, you can be a human.
Okay.
Yeah, so that,
Can you inject the prompts? So instead of being another agent, are you able to change some of the agent's prompts? Or
No, you can't
okay.
just change the prompts like that. I mean, if you want to change the prompt and like help the agent type the prompt in, I think it can be done in a custom way, but not in the current ChatDev format.
Oh, but the repository, can you change the prompt?
Yeah, yes, you can add your own prompts, you can change the
But
prompt. Yeah,
you have to do it before you run the program.
yes,
You cannot do it halfway, right?
yes.
Ah, okay, okay.
Yeah.
Okay.
So if you really want to have your own prompts for the AI, what I recommend you to do is you don't use ChatDev for that. It's easier if you just type it into ChatGPT.
Okay.
Yeah.
Nice. All right, thanks.
Okay, so this is the overall ChatDev process. Over here, we have stuff like, we have a designing, coding, testing, and documenting. So this is, they say, simulate the waterfall model. Okay, so I guess this means like you start from the top all the way to the bottom, like waterfall model, right? Yeah. So each of them, in each phase of the waterfall model, you have different agents that are involved. So like for designing what to come out with the product, we have the CEO, we have the CTO, we have the CPO, the Chief Product Officer. The coding, we have the programmer and the designer. So they're quite cool. They also have this thing called the designer, which basically if you need some assets, like for example, images, they can call the OpenAI DALL-E to generate the images. Okay, the programmer will come out with the code and then they can like leave placeholders for the image. So I thought this was quite cool. So they automated something that I've been doing by hand. So like I've been doing some Py games as well, by hand to like create some maze, create the various games like Snake and so on. But I've been like copy and pasting the image inside the folder myself. So they managed to automate this process. So that's quite cool. So in the testing, we have a reviewer and a tester. Okay, so the reviewer is supposed to give like inputs about whether the code is correct or not. The tester is supposed to test it out in the IDE. Okay, but I don't see this testing code anywhere in the ChatDev. So I might have missed it out, but it'll be better if the tester could just do directly in the IDE and give the error message back. Okay, so documenting is basically, there's 4 agents that come up with like the specifications and the manual. Okay, don't be fooled by these stages. Okay, in the illustration diagram, it looks like all 3 of them talk to each other, right? Like the CEO, CTO, and CPO. Okay, in actual fact, that's not the case. In actual fact, if you look down here, it's only 2 people talking at one time. All right. I think this is actually quite a smart move. All right. Imagine if you have 3 or 4 agents talking, they will just keep overlapping with one another. This is like also like how humans talk. Okay, if you have too big a group, your group will have problems. Okay, problems communicating. So I thought this was a smart choice. So within each of them, like the CEO and CPO, one will be the user and one will be the assistant. So the user is the one generally with the tasks that needs to be fulfilled. So like the CEO says, I want to create a Wheel of Fortune game. Then the Chief Product Officer will be like, yes, boss, what can I do for you? How can I do it for you? Yeah. So basically you start off with a task at hand, and then you go to modality. Modality maybe is like, oh, I need to create it in the form of a game or Python. Again, maybe modality is a computer software, because there are other modalities as well. There's like stuff like PowerPoint, Word. I mean, you can use it to create that also. Language can be like Python. Okay, the code. Okay, this code is basically like what are the main.py and so on. So you can see that majority of the ChatDev process, okay, is code. All right, and I think this is quite reflective of actual software development process also, because this part is the longest and you need to iterate many times. Okay, iterate over like your programmer, your designer need to add in, your reviewer needs to say, hey, there's something wrong with the code. Your tester needs to say, hey, there's something wrong with the code as well. Yeah, so this is quite reflective of how code is done. It takes very long to do this coding part. Then once the code is done here, the specifications will be created by the programmer itself, like what are the requirements, and then the manual will be created actually by the programmer as well. So actually, I don't think we need the CEO here and the CPO. Yeah, I mean, what do you all think? But I just think that actually the programmer is enough for the documentation. So this is roughly how the ChatDev is done. They go through different phases. Each phases, we have different personas to go and process the stuff. And what happens is from the start, we have a very, very broad task. So you can see at the start here, we have a very broad task. And at the end, what we will have, we have specific outcomes. We have the specific products. So at the beginning, the idea is very, very broad. The idea is like super vague. Give me a Wheel of Fortune game. And towards the end, you have the working game itself, right? And all this is done through iterating in a conversation style. At each level, we iterate in the conversation style. Then we'll output like modality or something. We output a certain decision. And this decision point will be used to condition all the subsequent generations, right? So that's really quite cool because the way you do this top-down approach, or they call it the waterfall approach, okay, it really mimics, I believe, human decision making as well. Like if you want to go from point A to point B, I say, okay, I need to take a bus to point C, then I take a taxi to from point B to point C. So like that's like the broad level task. I break it down into like broad level subtasks. So the first part is bus, second part is taxi. So then condition on a bus. Okay, what bus should I take? So the next person should make decision based on that. So this level of chain of thoughts over a hierarchy, I like this idea a lot. So you start off with a very broad goal. You use chain of thought, okay, to get a more specific goal, a more specific goal, more specific goal. In the end, you get your product right at the bottom. All right. Okay, questions on this diagram, because I think this is more or less ChatDev. All right, I described it in one diagram. Anything you want to ask about this diagram?
No, this looks good.
Okay, let's move on. All right, so obviously I don't think ChatDev is very remarkable yet. The idea is there. Execution could use more work. Okay, let's see why. Okay, let's just see what ChatDev does. Okay, so this is the waterfall model as I mentioned just now. You break up into linear sequential phases, all right, and then you pass down the phases to each other, all right, whatever you decide to talk to each other. Each phase depends on the deliverables of the previous one and corresponds to the specialization of tasks. So yeah, I mean, it's quite similar to what they have earlier, like the designing, the coding, the testing, and then the last part is documentation, which is not really here. Yeah, but I guess if you consider maintenance as documentation, I guess, I mean, it looks about the same. But the idea is sequential processes, right? And this is something quite useful for prompting because it fulfills the chain of thought criteria, which is you generate stuff all the way from broad to specific using chain of thought. Okay, whatever you generate earlier will be used to condition the bottom. Yeah, it's quite cool because you look here, the chain of thought, right? If let's say this is like your context, all right, then you have context, and then you have you have the next level context, and so on. You can actually treat this as you can treat this as a conversation, or like this is like what you ground your conversation to be. So each of these two people, when they talk to each other, they are just like one part of your structure of the entire like generation. So towards the end, you will get like Python code or this because that will be all conditioned on like the context, which is like I want a Python code, I want to create a Py game. So yeah, I quite like this idea, right? But the way we implement it, I don't think the conversation approach is the best way. All right, so let's see why. Okay, let's see why. Okay, I'm going to skip this slide, okay, because this is similar to what I talked about earlier. So there's 4 different phases here. Okay, so what are the key things that they did in ChatDev? So there are 3 things I'm going to cover. First is role specialization, which is over here on the left. Second is memory stream. Third is self-reflection. So all these 3 are what makes the agents. So first, role specialization. Right? How do we get like the CEO to become a CEO? You know, how do we get the CTO to become a CTO? It turns out that they just prompt it with just one word like that. You are a CEO for decision making. You are a CTO for system design. You know, there's something like that. They just basically give text. Okay, so imagine one day, you know, you want to become like a skydiver. You can just say you are a skydiver. Or like one day you say you want to solve math. You are a math solver. Okay, obviously you can get my drift here. It's not going to work for everything. Okay, it's only going to work for things that text can condition well. All right, if let's say you want to be a role that requires specialized skills, just using text itself is not going to cut it. You will need to give the agent some tools, and you will need the agent to call on these tools reliably, okay, which is currently still a problem for agents in our LLM agents. So right now, ChatDev is a very, very naive method of zero-shot prompting. Okay, you prompt, okay, because this is like, you can then use this prompt, this context to ground the generation for maybe like the CEO, and then the CEO can generate stuff that sounds like a CEO, right? So I thought that this idea of zero-shot prompting was quite interesting. Okay, because it could be like how nature like governs some of our behavior because of through our genes we've been told, okay, this is like the behavior that you should exhibit. So something like that. Okay. However, after I use ChatDev, I realized that this zero-shot prompting is not sufficient. Okay, it's not good enough basically to use zero-shot prompting to get all the kind of criteria you need from that role itself. Like if I could be a CEO just by telling the AI agent, you are a CEO, then why do we pay millions of dollars for CEOs worldwide, right? We could just use an LLM, we just say you are CEO, do the decision for me. Okay, so obviously there's something missing here. Okay, if not, we can replace everyone with AI agents, right? Yeah. So this is okay, so this one, just ignore this part. Okay, this part here is actually not correct. Okay, not every agent has both user and assistant. Basically, what I want to say is every agent can be user or assistant. Okay, so it depends on the use case. So it's like whoever comes up with the task should be the user, and whoever executes the task should be the assistant. So each of them will prompt each other until the user is satisfied with the task. The user will come up with an end token, and we will end the generation there. Okay, so this framework of user assistant is exactly like how the CAMEL framework does it. Okay. Questions for this? Okay, if not, I'll go on to the next one. Next one is called memory stream. Right, this memory stream is actually nothing new. This is basically the same as when you talk to a chatbot, the chatbot will remember your past few messages and use your past few messages as the context. So let me just write here. So like past messages, and then like maybe the user will say do this, and then the assistant will generate here. Yeah. So what happens is that we have this memory is in past messages. Okay, so the past interactions of the user and assistant will be here, like user, assistant. Yeah, so you have all these things to ground it, and then the assistant will generate something that it's relevant to the stream of exchanges. So like over here, language Java. Okay, too hard. Then you generate again Python. Okay, so if I didn't have this memory, I would maybe just repeat Java again. Okay, so this memory stream is basically conditioning on what has happened in the conversation so far. And of course, if the conversation is too long, you probably cannot store everything. Okay, so user and the assistant all have their own memory stream of the past. Okay, the assistant will have the user's latest instruction as the context as well. Again, you keep repeating until the user comes up with an end token. So that's memory stream is basically just two chatbots talking to each other and using the conversation history to remember stuff. Okay, all clear on this? Yeah, I think this is quite standard. So unfortunately, as with academic papers, they had to use math. So let me just show you the math formulation of this. Ta-da! So this is how it looks like in math. so I mean, I'm just going to briefly cover. So we have the user's message here. We have the assistant message. This forms your context, your memory context. Okay, and the assistant, when they come out with a decision, they'll form this ST, which is made with this phi function, which is basically a large language model giving the output. Okay, we update the instruction with a certain action again, and the action will be, sorry, not action. This basically is the large language model that generates the assistant message, and this is the large language model that generates the user's message. So don't ask me why they did all this, okay? Because honestly, it's just LLMs generating stuff, okay? This looks a bit too complicated. All right, I didn't really like the notation. Then you add back your message, add back your output from the assistant. Okay, so I'm not going to cover this because I think it's overly complicated. If you are interested to know how it works, you just look at these words here. I think these are they relate more to the human mind, all right? This one is more for academics. So we leave it as that. Okay, so next, self-reflection. Okay, how to do self-reflection is something quite critical. All right, there's actually quite a lot of papers on reflection. So I'm going to list out a few of them. Some of them is called reflection. So basically, like after LM agent does a task, ask it to reflect. Okay, so this very simple approach of asking you to reflect, and then based on your reflection, redo the task again, has led to like almost 50% increase in solve rate in some ELF world, in some RPG world in this paper. So just asking for reflection is a very powerful tool. I mean, you can try that for your kids as well if you have kids. Like if they do something, you ask them, why do you do it? Then based on why the kid reply, you can say, actually, that doesn't really make sense. You should do something instead. So reflection is useful, but reflection is also limited because it's only as good as the person giving you the reflection. You know, if you cannot reflect well, there's no way you can improve. So if you cannot criticize yourself well, how can you improve, right? You can only improve as much as that criticism or that reflection helps you. So, but self-reflection has shown to improve performance quite a lot. The other one that improves performance quite a lot is to verify and react accordingly. So there's a chain of verification. You can read that paper. So basically, you ask the LLM to verify using external tools and then prompt back again. So this like environment feedback. Yeah, I think both are important. Here we just talk about reflection only. Okay, and you can see that this self-reflection tool, rather than in the reflection way that the LLM agents reflect themselves, what happens is because we are doing pair kind of conversation, the pair will reflect as a group. So you look at this like the normal way to do it. Like you want to do the code, you ask it to implement all methods. Okay, and the programmer will just type out everything. Okay, so if we do in a conversation, okay, we can ask okay the other person like, okay, this can be like the critic. Okay, this guy is the critic or the reflector. I mean, this is actually the user. The person can say, hey, is there anything that is not done? Then the other agents can say, oh, I haven't done this thing, I haven't done game.init. And then the CTO can say, okay, go and implement it now. All right, then, yeah. So this is, okay, these are actually different people, but the idea is that because of the way that we converse with one another, all right, one person might catch the mistakes of the other person. So they call this thing with a very cool name. Okay, anyone want to guess what they call this in the CAMEL paper? I give you a hint. It starts with I. What did they call this method? Okay, you can shout out if you think you know the answer. Inception prompting. So they came out with the name called inception prompting. Okay, actually it's just like self-reflection using different agents. Okay, and so if you can actually do the thing, all right, you can see that like even for bug fixes, one person can write the code, one person can say what's the problem with the code. Okay, then another person can say in the next one, okay, what you need to do, okay, you need to change using this. Then the programmer can say, okay, I'm gonna type it out. Right, and then at the end, the tester can check again and say that, okay, I run it on my environment and it passed the test. Okay, so actually I was looking for this because they have this symbol here in the paper, which is, it looks like an IDE to me. So I thought that they executed in the IDE. I went to look through the code for ChatDev. I couldn't find any part that tests in the IDE. So I guess this could be implemented, but right now the ChatDev that I use, the one that they have it on the GitHub, I don't think they do this part, which is why the Wheel of Fortune game just now didn't really work out fully. All right, I mean it could run, but the game couldn't be played. All right. So results for ChatDev. Hey, not bad. Oh, sorry. Yes. Prince, you want to ask something?
Yeah, so I want to understand memory thing for this different set of actors. So for example, tester, programmer, and CTO is there. So is their memory independently managed as a different, okay, programmer's memory is different, CTO memory is different, or they are combined together in a bigger memory chunk so that every actor is aware of all other actors' previous actions? How would that look like?
Okay, I like your approach because that's exactly my criticism of them. They don't have. So the memory is only limited with the memory of the current conversation itself. So it's literally a chatbot memory. So after, let's say the CTO tells the programmer do something, then when the CTO next interacts, the CTO will have no recollection of what happens before that. So it's like starting anew. The only thing that the CTO will have is that they have the prompt, you are a CTO, you are great at tech, that kind of prompt. Yeah, you only have that as the context. You will lose out like all the decision-making stuff that you have done earlier on. I mean, the only thing that you will bring back is this one. The only thing that you will bring back from the decision-making is this thing, task modality language, because all these are like meta decisions that are passed on to the conversation agents. But the agents itself, to the best of my knowledge, they do not carry over memory after their conversation is done. They will basically forget all their memory of that conversation. So that's not a good thing to do, of course. That means that you need to keep repeating stuff to the agents. That's something that I think can be improved, because if you have memory, a memory bank of what has been done, I mean, they might even store it in a knowledge graph or something. They might even store what they have experienced, and then they can use that to ground their decisions in the future. So we have a true learning agent now. Okay, unfortunately, that we are still far from that, but that's the dream. Okay, if you can do something like that, your agents can truly learn. I think this will be much better, because lessons that you learn from one program can translate to another program. So even when you generate different outcomes, your memory might actually carry over. So I think that will be the, like, towards the end game. If we can do that, we have like solved a lot of things that agents can do. There's also another problem with memory, is like if you have too much memory, how do you store it? How do you retrieve it? So retrieval is a problem. I mean, memory retrieval techniques like retrieval augmented generation, they have its flaws. They cannot retrieve everything fully. So the more you store, the worse you might perform. So there's a lot of issues with that. And all this needs to be solved first before LLM agents can really do properly, can really learn actively.
I think that is, I like that point that storing memory maybe in the knowledge graph, and just like humans can be able to fetch long-term and short-term memory, where short-term memory you can fetch from the knowledge graph, some subgraph, and then something like that. Yeah, but yeah, I like that knowledge graph can be used for the whole memory thing.
Yeah. So what we have just discussed is not in this paper, by the way. These are just future ideas that I have. This paper is really very simple. It's just the chatbot memory, which is the memory of the conversation.
Thanks.
Yeah, good question. Good question. Thanks. All right, so let's move on to results. How impressive is ChatDev? So the paper said that they managed to do like 70 user requirements. Okay, not managed to do. They tried it out for 70 user requirements. How are these requirements generated? I don't know, but they look to be quite simple ones, because if you look at the earlier diagram with all the different products, they look like those kind of 3 or 4 files can do, and like some kind of like graph, maybe a simple game. Yeah, but nothing too complicated. You definitely don't expect them to program MapleStory or something with this ChatDev. Okay, I don't think it's possible. I mean, you want to create even simple mobile games like Candy Crush, I also don't think it's possible, because there's just too many files. All right. So on average, they generate about 17 files per software, including the manual. Okay. Elevated code vulnerabilities 13 times. Okay. Software production time of about 409 seconds. That's about 6 minutes. 8 minutes. Okay, so like for the Wheel of Fortune, it took it 5 minutes to generate. I also did a Gomoku. Gomoku is 5 in a row, the stones. It took about 3 minutes. I also did one Pomodoro app. Pomodoro is like the timer, when 15 minutes up, one orange will light up. So that's called a Pomodoro timer. That one took about 3 minutes or so, but the app didn't work. so yeah, I was trying to try out different things. Yeah. So only the Gomoku work. Okay. So I will discuss why I think this is the case. Okay, so they spend about 30 cents. Okay, in order to generate a program. Which, to be honest, if the program works, is a huge cost savings, because a programmer can easily cost you thousands. Okay. Yeah. Or more than that, depending on how good the programmer is. So if you can replace that kind of programmer with a GPT, or like with a group of agents, you can save a lot of money for your company. But fortunately for the software programmers out there, all right, LLM agents are still far from replacing software programmers. So This is something that I don't think will be anytime soon. All right, so still have the job. Don't worry about it. Okay. What they found out was that conversation, okay, like managed to find out at least about 20 types of code vulnerabilities, okay, and more than 10 types of potential bugs just by discussion. So earlier I said that, they didn't really test it the IDE. Maybe in this paper they use the IDE, but once they release the code, open source, the error correction seems to be like just based on the prompt. Okay, but remarkable. If let's say you can just based on the prompt, you can correct your code. Okay, it's quite it's quite ingenious, because like a lot of times we don't know the error until we run it. So if GPT can simulate the code without even running it, that's quite incredible. Unfortunately, we all know that this is not going to happen. Even the best programmer, you look through and say that the code won't break. The code is great. When you run it, it might still break. Okay, there are some hidden dependencies or this that's not on the code itself, not on the prompt itself. You cannot just do your error correction just based on the prompt alone. Okay, so this pretty much sums up the benefits of having peer review or having a conversation and having one other person reflect on the output of the other one. Okay, you can correct code in this way. So overall generation statistics, the code size is actually pretty small. Like I realized you only generate about 2 to 3 files per software. Okay, they say max is about 8. Okay, and there's a reason for that, because all these 8 files need to fit in one single prompt. Okay, your context length for GPT is about 8,000. So if you do 32,000, if you use the larger one, if you do any more than 8, I think you can't fit in the context length. Okay, and this means that whatever you use for ChatDev is limited to your context length. And in fact, I've done, there's some studies that also show that the longer your context length, the worse your generation, because there's too much to condition on. So this is a huge problem for ChatDev, because if you want to do complex games like MapleStory, you have a lot of files. Okay, and your files need not just be in the same hierarchy, they might be in different hierarchies with different folders. It looks like it's going to be difficult to express all this. I mean, even if you summarize each of these files, like you can say that, okay, main.py is to do the main game itself. Player.py is to statistics of the player. So you could maybe do like a totebot, like of brief descriptions. You could do something like that, all right? But in very, very large things, you could actually have like thousands of files for very, very large kind of systems. It will still bust the context length, even if you do a summary of the descriptions. So the only way to do this, okay, in my opinion, is to do it by hierarchy. So you have like the meta agent. So you have your meta agent, let's call it MA, meta agent. We'll do like folder level. So you have folder 1. Let me just put here. Folder 1. And then we have another one here, like folder 2. Yeah, so maybe at the top level, the actions are by folders, like, okay, these are the folders I need. Then at the bottom level, given the folders, okay, I then do my files. Okay, so this is just an example of a hierarchy. So your agent at the top doesn't access the files at all. It just thinks in terms of folders. And the agent at the bottom just thinks in terms of the files. Yeah. And each agent can also be specialized to do different kinds of files. So that like one can do documents, one can do PowerPoint, one can do Python code. So if we spread out, like spread the load using hierarchy, I think we can actually potentially increase the number of files to thousands. Yeah, which is not possible right now with the current ChatDev, because they just use the prompt itself. All right. Next, asset files can up to 21. That's fine, because it's just images most of the time. Okay, document files about 5. Okay. Oh, sorry, about 4. We look at the average. Okay, let's take a look at the average. Okay, lines of source code, you can see is actually very, very short. Okay, 131 lines. That's less than my strict JSON Jupyter notebook. I have more than this number of lines in that one file. So you can see that the limitations of ChatDev is you can see over here. Lines of dependencies about 3, means maybe you only import 3 other files. Okay, because I guess your code files only have 4, so it makes sense. Like your one main file import the other 3. So I guess that's about it. Lines of user manual. Okay, user manual, I give it to them. GPT is great for user manuals. Okay, they can come out with free flow text. Okay, version updates. Okay, this one I don't know what this means, but I guess this means like the requirements, dependency, and so on. Software redevelopment is like if you need to redo again, if there's an error message, redo the chain. So this like the feedback mechanism, it does it like on average 1.4 times. So overall, my verdict for ChatDev is that works well for simple programs. Okay, if programs are too verbose, cannot fit in context length. Okay, and another thing that I want to say is that the way the modules work with one another is not well captured. Okay, because a lot of times I see the error message is that, oh, you forgot to import this other file. You forgot to import your other file. So it's like they know that, okay, I need to generate all these files, but somehow in the code, it doesn't reflect that, okay, I need to import the other file inside. So the dependency graph is not very well established for ChatDev. Okay, based on my 3 experiments with it. Okay, and I think this is indeed the case because in the grounding, they did not ground by like, okay, they might ground by descriptions like that, but they did not say in the description, this is not done. Okay, they did not say in the description, call player and like will or something like that. So it's like you don't have a linkage of like where your files are. Okay, maybe it's better to draw in a graph. So it's like if let's say this is your main.py, we want to kind of show that, from player. So this is like a dependency tree. So main.py and player.py. We want to kind of say that in your main file, we want to import the class called player. Yeah, so something like this is kind of missing in the context. That's why when they generate the main file is typically absent of this kind of dependency like player. Like for the Wheel of Fortune game, they wanted to import the wheel, they wanted to import the player. In the end, what happened? Everything is generated in main. Okay, so the main.py generates like all this kind of thing itself. It didn't really import from the rest. Okay, even if they import from the rest, they did not call it. So these are some of the things for larger projects. I think there will be problems using ChatDev because of all these kind of things. Okay, so this again highlights the role of a software engineer is not easy. Okay, not only you need to code well for one file, you also need to know how all your files link to one another. And that's what AI doesn't do very well right now. Okay, questions on this before I move on, or any comments you want to add?
Will be interesting to know the average token count also for these overall program level, the task level.
I don't have the statistic right now, but I think it might be somewhere in the paper. Yeah, but you can see later the programs I generate, you can count the tokens, but it's about 30 cents. So if you convert the 30 cents back to tokens, I think you can get the number of tokens, maybe in the 20 to 30,000. Yeah, to see how much it costs. But if you use ChatGPT 3.5 Turbo, 30 cents, you can convert back to the number of tokens. That's about the total amount of tokens that this whole process of ChatDev generates.
Yeah.
Okay, so now it's time for me to critique this system. Okay, I critique a lot, but this is the time to critique even more. All right, so as with all my sessions, usually I'm not very satisfied with the state of the art because it's very hyped up, but it's actually not very good. It's hyped up, but it doesn't perform as well as I expected it to. So why is it good? Oh, I love this part about broad to specific. It's very in line with how I do chain of thought as well. It helps to guide the generation, and this is great because in the waterfall framework, you start from like the product requirements, then you move on to what are the modules, and then you move on to implement them. Very good. All right, this is a thumbs up for this system. Okay, this self-reflection is there. Okay, because of the way the 2 agents work. So that's again a plus point for this paper. And what's not good? All right, can they generate code that they have not seen before? Okay, so I mean they've given the example of Gomoku, the 5 in a row stones one. There's so many programs doing Gomoku out there. You search Gomoku Python on Google. Okay, I think at least 10 pages do Gomoku. So, do I really need a software agent process to generate me a Gomoku when I can just copy from a GitHub? All right, so that's why I tested Wheel of Fortune, because Wheel of Fortune do have, to the best of my knowledge, there's no Pygame implementation of it. Indeed, it doesn't really do it. well. Okay, so if it's out of the training distribution, your ChatDev process, okay, even though it involves many agents, so all these agents are still trained using ChatGPT. I mean, ChatGPT is the base agent. Whatever ChatGPT is trained on, it's good at. Whatever ChatGPT is not trained on, even you put 1,000 agents talking to one another, people like to say you have emergent properties if you have multiple agents, right? Even you have this emergent ability, you still have a capability limit. Okay, so if you don't have the right tools to augment it, agents talking to one another is not going to cut it. You are not able to break through that barrier and generalize out of distribution easily just from agents talking to one another. So this ChatDev is a proof of concept of that agents talking to one another cannot solve everything. Okay, you must still be within what you've seen before, or you must imbue it with some external tools that can help you to solve this. Okay. Second, all modular codes are part of the same prompt. Okay. So basically, like main.py, player.py, all this are part of the same prompt. What if the program has many parts and cannot fit in the context? So I talked about this earlier. If you have 1,000 files, it's not going to fit. Okay, so this is the limitation of ChatDev, because if you want to show all your programs at the same time, this is the problem. The way to solve it is hierarchy. At each level, you only attend to a few things. You don't attend to everything. Then you have the bandwidth to see everything in your respective layer. Okay. Next, the modular codes may not even refer to one another. Okay, this is the thing I was talking about earlier. The dependency graph, all this is not captured very well. Okay, one way to help to solve this is maybe to put the dependency graph in the context. You need to say that, okay, your main.py, okay, needs to import player class from player.py. So if you say something like that in your context, okay, or you could just say that, okay, given, okay, player class from player.py, okay, functions of player class is to simulate, stores the score of player methods. So basically you can give like the description of like methods is like add score, add points to player. So if you can do something like this to give like what needs to be imported, as the context, I'm very sure your main.py can generate something like that, because you are basically conditioning it on a function. So it's like a domain-specific language here. You already have something that you have created. You want it to use this specific, in my app challenge, I call it primitive functions. If you have this kind of primitive functions you already have, you can use these primitive functions and condition your software so that your software can use it in the output. The LLMs can use this for output. Okay, so there are multiple ways to do this, whether is it graph method or this condition. I think this condition will work better because you give more information to the LLM. So the LLM knows how to use this class. Okay, so these are just some of the bad points of it. They execute about 86.66% of software flawlessly. Okay, half is because of external dependency, incorrect version. If they did not really test in the IDE, like what I saw in their code, then this is understandable because they don't have the error message to say that, hey, your Python version is wrong, or you're using Pillow, the wrong version of Pillow. All this you need to test in the IDE to find out. Okay, I mean, even in Chip Huan's book on the bringing LLMs to production, she also mentioned she spent days trying to debug code that a colleague has pushed onto the Git, because they have different versions of Python. They spend days figuring out that everything is the same, but their Python version is different. That's why there's an error. So if you need to have a way to execute this in a sandbox environment, and your sandbox environment must be the same for every single one in the company. So I think this is something that I think can be implemented. They can just use Docker or something. Yeah. So it's quite easily done actually. So I think ChatDev can be improved quite easily with this step. Token length limit issue, I think the hierarchy might solve it, but this is a difficult thing to implement. Okay, so we contrast this. Okay, I might do another video on MetaGPT. In contrast to MetaGPT, MetaGPT is another kind of agent thing where they have like different processes also. But what MetaGPT does is that they have like a very rigid like workflow. I mean, it's very similar to ChatDev, but theirs is how would I say? They actually have the error correcting loop much more ingrained in that framework. Okay, better error correcting loop. And what happens is that they can execute 100% of tasks given. Okay, they can execute, but they may not complete it. I mean, but at least you compare to ChatDev, compared to Meta GPT, I think Meta GPT has a more rigid process of error checking, has a more robust process. So maybe I'll cover this video next time, because I think Meta GPT is also quite popular. Okay. Initially, I thought ChatDev was better than Meta GPT, but looking at the implementation, maybe Meta GPT might be better. So yeah, we'll see how it goes. Next thing, okay, this is the one that I described earlier, no sandbox testing. Okay, just observing the code. This is another very important thing. Like, to specialize as a CEO or CTO, I just tell you, you are a CEO. Okay, that's not going to work, all right? That's not going to work. Imagine telling a human you are a CEO, then expecting him or her to make decisions. Okay, you need to be trained well. You need to have the right skill sets. Okay, you need to know how to call the right people on right networks and so on. So all these are quite hard to model, but definitely one thing that's missing is skills or tools or APIs. Okay, or skills. You need to imbue with role specific skills. So all these things here, yeah, role specific skills are missing. Okay, and of course, as they do different programs, they need to learn as well. They need to not make the same mistakes so that you can progress. Right. So this is what Prince was talking about memory just now. This memory is also my favorite research topic. Okay, I'm a memory person. Okay, I believe memory is the key to unlocking AGI. If you can solve memory, you can solve a lot of things, because we can solve learning. So right now, this memory is very rudimentary, just conversation-based memory. We need to make it bigger. We need to think bigger. Think in terms of multiple interactions to preserve the memory across there. Multiple products, multiple tasks, you also preserve the memory. And this memory might also help to give it new skills. You can consolidate your memory and get a skill out of it. Like, you can do a reflection and say, hey, actually I should do process A every time I see this category. Then that can be, process A can be your skill. Yeah. So dynamic skill learning, something very exciting to me, something that is very hard to do. so I think this won't be done anytime soon, but I can see that in the end outcome for agents, we will need it to learn its own skills as well. Okay, so I pause here for a while. Any further, like, you want to add into this part on why ChatDev is not good, or why ChatDev is good? You can chime in now if you want to. Okay, if not, let's move.
Sorry, I have a question. You mentioned that it generates the folders structure also, or does it not generate the folder structure?
Right now, I haven't seen it generate the folder structure for my use cases, but maybe for more complicated ones, it would. What I talked about folders just now is that I'm saying that if there's a lot of folders and so on, it may not be able to generate the code properly, because like the prompt, because the prompts that we give it, like the number of code files or this prompts is limited by the context length. So you can only put in that many files. So with regards to folders, my point just now was that I don't think it can handle it very well, because it will bust the context length.
Okay. Because yeah, I mean, it's good until you need to maintain. Like, obviously generation it looks good, but we all know that once the code is generated and the files are messy, or like the folders are messy, it's quite hard to debug, like, as a programmer. And so what you're left with is a unmaintainable code.
Yeah, I mean, there's a saying, like, it's easy to create code, but it's hard to debug. So you can create things that work for now. The moment the version change and so on, you need a very capable agent that knows how to, like, access those various documentation to fix it. Documentation change, we need a way to fix it based on how the documentation has changed and so on. So that you need programmers for. And I think that right now ChatDev can't do this yet.
Have you also the next question is, can it generate images, or like different kinds of types of files, like not just text files or Python files? Do you think it can do PNGs, SVGs?
Yes, it can. So just now someone asked about, like, whether humans can be in the loop. I think it was you, right, Chicken? So
yes, that's right.
yeah, I forgot to mention. that, in this phase, like the coding phase, if you add in this designer, the designer can, based on the requirements, okay, because like there'll be a prompt say, let's think step by step and so on. So you can ask as the main prompt is like, what are the images needed? So the programmer can work with placeholder images names, and the designer will then fill in this image with the generated stuff. So how they generate OpenAI DALL-E. I mean, you can use other tools as well, open source tools as well, but there's a way to generate images as well. In fact, the output here can also be a PowerPoint file, can also be a document. It's not just Python code that this can generate.
Okay, nice. Thanks.
Yeah. So where are the humans, right? Actually, over here, you can have a phase called like human-computer interaction. You can be the you can be the user. So like the user is the human, which is like how it's normally done, and the AI will be like the programmer. So you can like order your programmer to change the code. Like and on a separate window, you can open your main.py. You can run the game or you run the program and say, hey, there's no start button, implement it. Then basically that's your user here, and then the programmer will say, okay, I will implement your start button. Then they will go and redo the code. Here's the generated code. Then you can test the code again and say, hey, there's no score. I don't have a UI for the score. Then the programmer will say, okay, yes, I'm going to implement the score. So there's a way to do this human-computer interaction here. You can have your own face. You can implement your own face in the ChatDev framework, a custom face. Did I answer the question that you had earlier?
Yeah, sure. I mean, it is still basic injection of like
Yeah, it's just prompt injection.
prompts and everything. I think probably like if this has enough, it's open source, right? If this has enough
Yeah. ChatDev is open
contributors,
source.
if this has enough contributors, I think that some people will find a way to improve the system until we get to a level where we can generate a simple, workable applications first. Have you seen this new beta called V0 by Vercel? Apparently, it can create whole websites already.
Oh,
Like so,
let
let me send it in the chat. Let me get the correct link and send it in the chat. But it's not available yet. I think it's coming into production soon. What this supposed to or promises is that it can do the whole website. So I think that is one good application. So I'm thinking for this particular ChatDev, probably a basic Unity game or basic Pi game or basic website. If we can generate the basic one first, then we can iterate to expand the scope of what it can generate. I don't know what is the LLM or what is the AI powering this, but this V0 is by Vercel, the company Vercel. So they have a way to either by multiple agents or some other prompt engineering to generate all the files and folders required, all the JavaScript and the HTML and CSS. So probably they use similar methods or something like that.
Yeah. I suspect for this, you need to have a better broad to specific grounding. So you need to ground firstly, like give me all the files needed. So that will be like the grounding. And then each agent at the bottom will then generate some files, like not all the files, like maybe 3 or 4 of the files and so on. Like they can group by web page, so each agent can do one web page. So if you want to do a HTML agent like that, I can see it being done if you modularize your generation.
Yeah, because I'm already using ChatGPT to generate some low-level SQL or like
ChatGPT is
HTML,
great.
CSS.
ChatGPT is great if you don't need to think, if you don't need it
Yeah.
to too much. Okay, treat it as a very low-level executor. It works great. The moment you want it to do lots of planning, right? You need to ground it with a lot of like past knowledge. Okay, you can only do process A with incident A, process B with incident B, and so on. So all these things is in your brain actually. This high-level knowledge, but it's very hard to codify it out. So if you could just get GPT to do the lower level ones, at the top level, you use more rule-based things to do it. I think it will work out fine. GPT cannot plan very well, unlike common hype. Yeah, I don't think GPT reasons very well either. Yeah, it just matches very well. So we need to use what GPT is good for.
Right. Thank you. Yeah, that's great.
Yeah. All right. So the last part here, some of the artifacts that they notice. Okay, these are not exactly cons, but they realize that there's repetitive expressions of gratitude, like thank you, good day, you know, that kind of stuff. And this is my take on this is because of RLHF. Like humans like to hear thank you a lot, so maybe that's why the agents keep saying thank you. Yeah, so maybe the ChatGPT is not trained to like say like, okay, I'm gonna end the conversation now, because that sounds rude to humans, right? So that's why when you have two ChatGPT agents talking to one another, neither one wants to end the conversation. So so this is what happens. All right, so they fix this through a hack. They just use a end token to so that the GPT agents will, at least the user will know how to end with the end token. So we don't have this never-ending dialogue. However, later I'll show you an example of why the dialogue may be an inefficient way to do things. Okay. So the other thing that I want to point out is that there's a limited ability to autonomously determine the specific implementation details. Okay. So this is again the limitations of planning. Okay? ChatGPT can only plan well if you give it the tools to plan well. If you ask it to free flow do the planning, okay, it may not do this implementation details well. So Chicken, you mentioned about the website by V0. Maybe they ground it in very, very specific website designing stuff. Okay, this ChatDev is too broad, too generic. It's not grounded in anything specific about games and anything. That's probably why it cannot do the multiple linkages between Python files well. So yeah, I also like to say that chat-based format may not be the best. Okay, you might need a more rigid framework structure to ground the output generation of LLMs. Okay, so some experiments I did. Okay, so this is in the paper. The CEO and CTO are discussing, like, okay, for Gomoku, what language should I use? Python. All right. And use the Pygame library. That's for later on. So I basically did a ChatGPT experiment. I said, okay, I just want you to output like the programming language and the module that you need. And I get the same answer, which with like much fewer tokens. You can see that this is like literally there's like 4 or 5 tokens. So no, sorry, like 1, 2, 3. Okay, I mean you also need to count you have to use the tick token to check the number of tokens, but you can see it's significantly less than this amount of generation. This amount of generation also hides the fact that each of these agent has a memory stream that fuels it. So this is not cheap, you see. You need to have a conversation. You remember what happened before that. The amount of tokens will explode with the length of your conversation. The longer you converse, the more tokens you need. Okay, but if you just want to say like, hey, for this task, okay, given this task, okay, given task A, what program should I use? Or what modality should I use? You could even ask GPT this. Okay, and then you can ask it like only give the answer without explanation. Yeah, you can do something like that in GPT. You might get the same stuff as what two agents converse with one another. Okay, why? These two agents are also ChatGPT. There's no difference. Okay, you can converse with one another. The main thing you gain is reflection. Okay, but if you have a task and you want to match it to the outcome, you don't need a conversation. So whatever conversation model that CAMEL is doing, that ChatDev is using in their framework, is not necessary for a lot of cases that I see. Okay, take a look at the replay log. A lot of them can be replaced with this. Like you can ask it to output a JSON, or you can ask it to output the answer like that. Simple problems can be solved simply. All right. So this is the quote of the day for today. Yeah, you don't have to use a conversation to solve everything. And I think this is one of the downfalls of ChatDev, because the conversation is very lengthy. It might lead to loss of information. Okay, so I think this can be replaced. All right, this part of ChatDev can be replaced for some parts of it. Like idea generation, you don't need a conversation. Okay, unless each of the agents have different backgrounds, Okay, because right now each agent doesn't have specific memory. If your CEO has memory of like his other corporation that he has done before, your CTO has memory of other programs he has done before, then yeah, a conversation might be a good way to bring out the best of both of them. But right now, because of the framework of how it's done, there's no memory, there's no past memory of what has been done outside of the conversation. It's not necessary to have the conversation. Okay, all clear on this? All right, so this is how the ChatDev Gomoku game looks like. Okay, I didn't use the image, but right now you can see that you can just like you can click on the thing and like one circle will appear. Yeah, so this is a five in a row game. You can see it costs about 24 cents, 0.024 cents. Okay, the number of tokens is there a number of tokens here? Number of prompt tokens is 11557. Number of completion is 3528. So Gomoku is fairly simple. All right. So this ran in about 3 minutes or so, and the game creator is runnable, is playable. So kudos to that. So at least Gomoku works. Right. So I tried to do the same thing in ChatGPT. So I only use like six words or 7 words. Okay, and I got a superior result to ChatDev. So you can try typing this. Create me a Gomoku game in Pygame, and then it can just run straight away like that. Yeah, looks way better, and like, oh, like what was all the conversation about, right? And you see the cost. Okay, actually it's not 0.01 cents, it's 0.001 cents. I didn't bother to check my OpenAI usage because I know it didn't use much. Okay, it's just simply just this prompt and then output the Python code. You just copy paste and run it. Okay, this is the Gomoku game. I give this example to just highlight how inefficient ChatDev can be. All right, because you can do the same thing with just one prompt. All right, Wheel of Fortune game. All right, so this Wheel of Fortune game, in the end, what happened is that they just created like this thing here. There's no wheel. There's no. I mean, you can key in some of the letters. It costs about 0.04 cents. The number of tokens, 20,000. Completion tokens about 9,000. All right, so it took about 8 minutes, 468 seconds. Yeah, so I think this is something that needs to be improved. Okay, Wheel of Fortune game is actually not that difficult to create. Okay, you just need to create the word, and then you need to create the key press. They got most of it right, but they lack the UI. Like there's no like someone have a score, maybe like round what, then like players. Yeah, we are lacking a few other things, but at least the basic game functionality I think is there. It's just not very apparent over here. Okay, so let's do a stress test. How important is ChatDev to create this Wheel of Fortune game? Can I create it myself? So again, I asked ChatGPT, create me Wheel of Fortune using Pygame. Right? Unfortunately, it didn't run. Okay. There's this variable spinning that didn't work out. So let's prompt the error message back into the chat. Okay. We asked it to basically ground it in the generation. I prompted back the error message, and then in the end, what happened is that, oh, okay, it gave me a wheel. Okay. But the wheel is supposed to be like it's supposed to be segmented. Okay, but I think there's some problem the code like putting the segments out because all the words overlap at the center. So I have 6 segments here. So okay, at least the wheel was created. Okay, then I realized that if I ask ChatGPT to just prompt the Wheel of Fortune itself, okay, it's a bit too rudimentary. It doesn't really know what is needed. Okay, so it literally just generated the wheel, all right, for ChatGPT. So I mean, there's some merit for ChatDev because ChatDev managed to do like maybe the word guessing logic as well. Just that the UI is not exactly well created. So I just thought, can I do it by multiple brought to specific prompting? So I create a minimalist Wheel of Fortune game. Yeah, because if I ask you to create the real Wheel of Fortune game, it comes out with like a lot of assets, sound assets, image assets, and so on. I want to do as little as possible. So these are the stuff that GPT generates for me. And I think this is a great thing to use. You can just use all this, okay, give it this this overall config file of what's needed, ask it to generate main, generate wheel.py, and so on. So that's what I did. I asked it to generate main, given that. And guess what? It creates a decent game. All right, there's no wheel now because I only generated the main without the wheel. Okay, but you can see that like over here, at least this I managed to key in the letters and it can guess, and then This part here is a bug, all right? It's not supposed to be you win. Okay, you haven't won yet. Okay, so at least from broad to specific, I could get a decent game out. Okay, though not completely working, missing certain elements. Yeah, so ChatDev has some merit. Okay, they're able to do these broad to specific steps. But the downfall of ChatDev is that they talk too much. All right, so pros and cons. Yeah, actually that's more or less the end of the presentation. Before I move on to the questions to ponder, do you have anything you want to add on to like what you've just seen? Okay, if not, let's talk about the questions to ponder. All right. So the first question is, will a ChatDev group of agents be actually much better than just having one single one do the task? So the one single one that does the task is like what I did for the Gomoku game and the Wheel of Fortune. I just asked ChatGPT, give me a game of Gomoku in Pygame. Right? So for Gomoku, it worked perfectly first time. Wheel of Fortune, I need the prompt from broad then specific. Right? So the question is the group of agents really necessary? So I'm going to give my take on it before like we open up to the floor. I think this is a group of agents only perform better if the group has value. So if it's zero shot prompting, it's actually very little value, because in terms of the way of what the agent would do, like you can actually just ask the agent to come up with just one single agent to come up with the steps itself, because by asking it to come up with steps, like doing chain of thought prompting for one agent is like mimicking multiple rows also, because the multiple rows, all the agents are the same agent, you see. So I don't think a group of agents is necessary in ChatDev's case, because all the agents are the same kind. Okay, with the same kind of tools. In fact, they have no tools. I mean, same kind of memory. So I don't think it's really needed. Okay, any comments on this question? Will a group necessarily better than a single person? Okay, if not, then I'll move on to the next one. Can we replace the entire workflow with just one agent? Okay, I think this one is yes, potentially. Okay, but one thing that ChatDev has taught us is that the process-based workflow is useful. So like the waterfall model or sequential steps. Okay, so you generate from broad to specific. It's very useful to condition the generation in that path. So I think that is the key lesson we can learn from ChatDev about this process-based workflow. Yeah, of course, MetaGPT does a similar one. In fact, they might do it better. We can cover that next time. But the idea of constraining the generation in each process and having this fixed rigid process to follow is a very useful one to constrain your generation to more plausible and more useful outputs. Okay, last question. How can we encode memory for each agent so that they can grow in experience? Okay, so this memory needs to be memory across episodes, memory across conversations. And then we need to like store the memory suitably. So maybe like knowledge graph or something like that. Retrieve memories well. So maybe the retrieve memories well can be like something like RAG, retrieval augmented generation. So once we get the memory part well, the agents would be able to learn from various experiences and maybe can potentially be better than currently. Okay, that's the end for today. Any last words before I end the session? Okay, so let me just end on the ChatDev slide. Okay, so I think ChatDev is a very interesting way of getting the overall flow of generation done from a very broad phase to a very specific phase. The idea is there, right? The idea is good. Execution could use some work because the agents are not well differentiated. The feedback from environment is not really there. Okay, there's also a lack of like constraint of like, for example, you have different files. How should the files relate to one another? This kind of overview of hierarchy is not there. And yeah, the agents at the bottom, they are not specialized enough to give good enough outputs. So if we can fix all of these problems, and perhaps we'll find more as we develop the agents framework more, I think this is a very useful process to follow. All right, this this sequential based model. Okay, what I may not agree with is that you may not need to use conversations each time. You could just prompt the large language model to output a potential action. Okay, so I'd like to end on this. I think this is overall a great paper, quite an insightful paper, but a lot still needs to be done for it to do more complicated tasks. All right, and yeah, that's all for today. Yeah, see ya.